Hello, everyone. This is a little bit of a different talk than I normally do, but here what I'm trying to do, my overall goal is to communicate an idea, and in some sense also try and develop a better way to talk about this idea. And so even if you agree or disagree, or even if I'm unclear, I really want to kind of have this be turned into more of a conversation, afterwards and ongoing, because this is kind of like a core concept that I'm not quite clear on the best way to talk about it is. So if there's any sort of way to improve this, that's why I would ask of you. So what is this core issue? The core issue is that I want to look at things very much from this developer perspective. How do we make sure that developers can continue to have like the high speed of iteration that they want, and how do we kind of focus on some of their needs as well? But let's go into a little bit kind of where I come from. So I spent a lot of time doing all sorts of weird things. Started off at Google, then went into the military, started building all sorts of interesting capabilities, got into cybersecurity, training our cyber teams, then went into digital service. This is where we kind of do a lot more of the review of existing projects, trying to kind of improve software quality, again, mainly in government and defense. Became a consultant, became a contractor, and all throughout this process, I encountered a very common set of problems. I usually kind of trim them down to be like, hey, we have networking problems, this is about connectivity, this is about distributed systems, this is about how do we make sure that all the things are talking in the right way. Next big category of problems tended to be mainly about users. I want to be able to manage users, I want to be able to authenticate them, I want to authorize them, I want to be able to control this and have set policies for these things. So it's very I can condense it to say that this is about users and how do we manage them, how do we control them, how do we organize them. Sometimes these users are humans, sometimes they happen to be machines or services, but still a very similar set of problems. But then there's another category, and those are real problems to be solved, those are really problems to be addressed. But this last category is what I want to focus on today, is this category of, I call it packaging. But it's an idea of how do we make sure that we have all of our things that we need for our software to run, or hell, maybe it's our hardware to run. But we need all these things for this to run, for it to be effective. We want to control it over time. This is a lot of what a lot of talks have been here today. And along the way, I encountered a thing that gives me a set of superpowers. It's this tool called Nix. And I want to be able to bring this kind of tool that is either relatively unknown or not as adoptable, but make it adoptable. Make those superpowers available to everyone. And that's a company called Flox that I'm a part of to make that possible. But I don't want this to be necessarily just a pitch about this one particular tool set, but overall that is something that I'm trying to develop. All right, so we're talking about software management. And there's a lot of focus on what does this look like when it comes to on the deployment side. Well, too much focus there tends to create this situation where there's a difference between what this looks like on the right and what it looks like on the left. So I want to create a far more parity between what developers are using on a day-to-day basis in an iterative way in terms of how they debug things and inspect things, and what they look like in production, right? As much parity as possible, right? We want these things to also compose well, right? I want to be able to have grab bags and concepts where I can take a thing and merge it with another thing and actually have something usable at the end of that. I want to be able to combine features, I want to be able to combine software, I want to be able to combine libraries and modules. And so composition is important. Next piece is reuse. I want to be able to reuse things. If I built something, I want to be able to reuse not just the exact binary at that time, but I want to reuse these libraries. I want to be able to have the benefits of this. And all throughout this, we can't just forget, hey, we also need to go into deployment. So let's not forget those needs either. So solutions. I call these almost solutions because they're pretty good. They usually get you most of the way. But I've often found a lot of these sometimes lacking. So, hey, containers seem to solve a lot of the problems that we have in the packaging world or in the software world, except when they don't, right? It's often containers provide too much isolation. So what do? We put something into a container, and then we break into it, right? We try to expose all the things, we bind mount everything in, or bind mount everything out, or we start creating network compositions in order to actually be able to interact with this thing, right? Too much isolation, right? A perfectly isolated text editor can't edit anything, right? We want our software to interact with each other. That's why we build it. And so that's even more so when the needs of a developer come into play, because I want to be able to debug things. I want to be able to look at things outside of the normal operation of that software. So isolation, or too much of it, can be its own problem. Hey, static binaries. This is a great tool if you have it available to you, but very often, non-trivial software really very quickly expands beyond the realm where that's a possible or feasible way to run things. Might work for one particular service, but hey, now I have several services that all have to interact. Again, I can't just say, hey, bundle this into one single little artifact that is easy for me to understand and track and manage over time. Serverless, very similar sort of issue. It's, how do I use this locally? Serverless often has a lock-in in terms of vendors. There's sometimes a lack of standardization. Also not 100%. Self-hosting all my services, great. What if I make my local environment, from a developer perspective, the same thing as prod? Well, now I run into sometimes issues of scale, issues of access, issues of networking. So again, we start to run into problems here. And in some sense, what we're looking for is these are all kind of approximations to this problem of being able to do packaging, and yet these are ways that we avoid the need for packaging itself. And I'm using that as the term for the creation of these things that are reusable. So let's go through kind of a little bit of journey of, say, a sample project and how this works. Let's start off. All right, step one. I've got nothing. I just want to start doing development. All right, what does that mean? Hey, I want to develop on some effort. I want simple onboarding, right? That's a very big need that we like. We want an easy development flow. I want to be able to run my local builds. I want to run my local tests, right? I'm very much focused on that kind of iterative, fast feedback cycle that we want to do, and we want to do something at not a snail's pace. I'm not going to plan out every single possible thing. I want people to be able to work. Cool. So quick iteration. That's like the primary goal here. All right. Well, at some point, I actually want to have more than this. I want a little bit of CI. I want to say, hey, I'm no longer the solo person on this. I have a team, or I have a group of people, or maybe we don't even talk to each other. We're just a distributed set of open source contributors. Now I need to make it so that, cool, it works for me, but how do I make it so it works for everyone else? How do I make it that I can test this sort of thing? How do I get a little more automation? Because me just pushing things manually is not going to scale forever. So here we start needing a little bit more CI, right? What does this mean? Well, hey, maybe I can develop. How do I make it so others can develop, right? So we start adding build tooling, start adding debuggers, scanners, linters, test suites, right? This is kind of the next phase usually that we end up seeing. And now often what it takes for CI to do its job starts to be of most importance. Cool, that starts to be nice. What do I do next? Well, let's get into the next section. Hey, this is a service, it runs, it's great, it does something amazing. Who knows what it does? But I want to get into prod because I want to tell the world. Cool, let's take those build artifacts that our CI produced and actually put them together. Let's stamp the appropriate services that they need. They need access to databases. They need access to other systems that need to be up. I need to configure these things. Again, let's look at those needs, right? Usually here, the primary focus tends to be the runtime I've chosen, right? So if I'm going to run this in Fly.io, I'm going to run this in serverless, I'm going to run this on a standalone instance, I'm going to run this in Kubernetes. At this point, that runtime orchestrator and its configuration, its needs, tends to dominate the conversation. And then once this thing is in production, now I need to operate this. How do I look at it? How do I inspect it? How do I fix problems? And then when there are problems, inevitably with any non-trivial piece of software, I want to now be able to go figure out what went wrong. So here, that ability to inspect, here, that ability to look at that runtime is going to be kind of the main thing that we care about. So this is pretty good. There's a whole bunch of things we did for us to get into production. Except, now what? It seems that along the way, the needs of each of these other steps began to dominate, become the focus. And, well, what if I want to go actually still iterate on my software, right? We almost forgot the needs of that original developer, that developer environment, that fast iteration, that ability to get the job done and improve our software and make fixes. And this is kind of a problem I'm seeing a little bit more and more of. So how do we ensure that we don't kind of lose this ability? So there's some examples. I've seen a bunch of examples where we say, hey, how about we make it so that that developer experience looks just like prod? Okay. So what do? We do tricks like this, where we say, hey, we're going to have our runtime system stand up some sort of a developer environment, and it'll look something like this, where, hey, it's running, and then we kind of give that local developer access to it. Okay, that's a way to kind of sneak in our tooling, our IDEs, our experience to look like prod, because it's really just another example or instantiation of it. So that's an example of that. We have examples where, hey, my local machine is basically just like a thin veneer over an access to something underneath the hood. And that might be some service that's like spun up remotely. It starts to be managed. But again, this is a lot of machinery that looks very different than the story we started with that developer just being able to iterate fast and do their work. Now they have to use all sorts of tooling. They have to kind of sneak their way into standing up all these services or get access to these services. And we've kind of lost some of that initial feel. Here's another example. This is more like VS Code style. But again, we're making a deployed, in some sense, a production environment just dedicated for the purpose of that developer. And we're kind of sneaking our way in for all our development tasks to be done there. Again, it's a perfectly viable solution, but to me, it seems like we're kind of missing something fundamental. So why are we doing this, right? All this sneaking in, like, what are we doing here? We're breaking isolation first off, right? Especially as we're trying to use our, let's say, development tools, our debuggers, our iterative tooling. We're sneaking into these containers. We're making changes. And now, like, we don't want that isolation at this point. We want to be able to integrate our tool sets in our environments. This is the trick we see often is, hey, let's bind mount everything in, bind mount everything out, and then, like, what was the point of containerizing to begin with is kind of what I ask. Orchestrating all of our services at some points becomes difficult, right? I need to have a whole set of, like, either a local Kubernetes, or I need to find out a way to deploy everything into a hosted one for the purpose of, hey, it's past the scale of what I can do in a local way. So why are these realms different? That's kind of the question I want to ask, is why is it that we have a completely different set of toolings and different set of interfaces, different set of deployment strategies, depending on whether you're developing or depending on whether you're on the deployment side? And it seems like this is not an ideal situation, right? For the developer, it's hard to, like, bring my tooling in and do things in an ad hoc manner that allows me to inspect. It's not ideal there. Not ideal for operations either, right? Because now that infrastructure is the only way often for them to actually be able to get their work done. So now you start kind of getting over-reliance upon that infrastructure. For production, again, it's kind of weird because we want to have things that are able to scale, but roughly what did we do? We just shipped our machine. Just it happens to be a machine that was built for us by the cyborg, the tooling. But we just shipped that coworkers, right? Our automated coworkers tooling, not that of the developer. And that's probably a good thing, but now there's a bit of a disconnect. This is not ideal for ops, right? You can't go inspect things in the way you normally would. Now we have to add a whole bunch of other things, a whole bunch of other monitoring tools, a whole bunch of sidecars, a whole bunch of logging frameworks to basically give us the information that normally you would want to have in a much more native way. So it seems like there's a problem. So why? Well, let's figure this out. Our build environment, right? It depends on a container registry, all right? That's something that's kind of usually external to Git itself. If we build an artifact in CI, that's nice, but the fact that we did so, or what that artifact actually is and where it's located, that tends to be kind of start to fall out of the being tracked in Git model. If we have our pipelines, often the configuration for these pipelines starts to leak out and sneak out of the being captured in Git and is now in those particular systems. That could be an issue. Our developer environments, right? Either we don't specify them, or they're in a README, or they're like over-specified and it's thou must run your developer environment using this VDI solution, or this VM, or inside of this container, and that becomes over-restrictive. So either we've under-specified it, or we've over-restricted the developers. Either way, in all these situations, our iteration cycle has slowed down. All right, hey, let's go back to the original thought. Hey, Git is this great thing that allows us to track stuff. Well, let's track stuff. Okay, so we keep track of build recipes, right? That should be a good thing. I think this should, generally this is already done. Cool, well, let's also figure out, let's record these build outcomes, right? Let's keep track of, what our infrastructure is. Here we're talking about things of, you have your Terraform. Hey, you have your Terraform, you have your Helm charts. These are things that specify what is the intent that I want my infrastructure to look like right now. Then when we run these things in CI, well, what actually happened? There's often additional details that you get with the real world. Real world tells you, okay, yeah, this is what you wanted, here's what you got. And hopefully those are the same, but sometimes those details matter. So those things need to be recorded. Let's say we have our services are now running, they're live. How are those things changing over time, right? There's outages. The real world actually has a say. Just because something's in Git doesn't mean that's actually current reality. So let's start understanding that those external events also take place. And so let's keep track of those things. Okay. Usually we call all of these things state. So we need to be really careful of where do I have state in my system. And let's actually try to minimize this. So let's try to figure out, well, can I put as much of that state as possible into something that's tracked, right? Put it in databases, put it in Git, put it somewhere where it's not going to just disappear, and I'm going to have to either kind of reconstruct it or figure out or discover it again anew. Hard to do. All right, and this is then, we want to leverage our automation, right? I think the previous talk was talking a lot about this, but let's keep track of some of the artifacts we're talking about. These are human edited, right? These are things where a human says, I want this to exist, either this resource or this service, or here's how I want to build a piece of software. Then we have stuff that's more like log files. This is stuff where we say, hey, the humans shouldn't keep track of these things because humans can't. We're horrible at these details. Instead, something else should kind of lock this down. And we've started to understand that putting these into our repositories, putting these into Git tracking is helpful because the humans are not as specific as our machines need to be, and therefore, let's lock these things down. State files are a very similar concept of, well, again, these are details that the humans probably don't need to necessarily track, or they probably are not good at. Again, let's track these things. Let's put them into databases and repositories so that we know what they are. All right. But fundamentally, I want to bring up this problem of, we need composition, right? Seems like we've often fallen away from this. So we want to do sharing. We need to kind of figure out, well, what are we trying to reuse, right? What's the simplicity we're aiming towards? And I kind of called out 3 categories of stuff that we want to be able to reuse and have sharing with, right? These are recipes. So if we're talking about the software, this is the build recipe for something. If this is something like infrastructure, this is your infrastructure declaration, either what's in your Terraform files, or this is what's in your CloudFormation scripts, right? Or it's in your Puppet scripts. These are kind of definitions of what I want my infrastructure to look like right now. But in some sense, these are recipes. These things are stuff that anyone can rerun. That's kind of the idea. I can give this to you, and then you can go build my software. Or I can go give this to my CI, and it can go deploy my infrastructure. Again, I can share it, I can reuse it, because other people in other contexts can make use of it. Now we get to binaries. This is kind of the blobs. This is, let's say, a Docker image that you push up and now is hosted in some registry. This is a piece of software. This will be bundled up in various different ways, but again, it's a actual binary that people are going to be running. You want this to be reusable as well, but you kind of have a different kind of reuse. You're not referring to the recipe where they're going to go run that thing. No, they're not going to rerun that thing and rebuild it. No, they're just going to use that thing as is. They're going to put it into some other context, into some runtime, and run it. These are usually declared in a very immutable sense. And then there's another type of a resource. I'm calling these snapshots for the moment, but this is a reference to something that can change over time, right? And as much as we might not want this, this is the reality, right? We have a reference to a service, reference to a database, right? That database is changing all the time, and that's as intended, but that is a reference to a thing, right? And that can change over time. We can snapshot this. We can try to kind of recover some aspects of reuse and sharing, but in some sense, a database in production, you're not going to necessarily, you can reuse it as it is in its current state. You're not going to be reusing all sorts of different snapshots over time, at least not without difficulty. So again, we need to have kind of a better way to communicate these concepts, trying to figure out what the right ways are, but I want us to be able to specify in our language and in our tooling, what are we reusing? Am I reusing that recipe? Am I reusing the binary exactly as is? Or am I reusing some current snapshot or current state of something which changes over time? Because how we talk about them will be different. And then lastly, it's, we want things that are reusable, and I kind of bundle this under the term of packaging, right? I want to bring back this notion of, we've sidestepped this a lot, especially with an overuse of containers as the escape hatch, as the I can now package anything with this, and which is true, but now it means I've lost a little bit of that reuse. I can't reuse these things in the ways that you normally would want to. If you go look at the standard way we build containers, it's very often the beginnings of it are very package-centric, right? It's I start with the distro and I'm bringing a bunch of dependencies, or I'm going to build something and hey, this is defined with some sort of a package set because I'm in the Go ecosystem. Here's all the libraries I need. Here's all the packages I need. Again, packages tend to have this composition and modularity, whereas things like these binary blobs, these containers, tend to be a lot more locked in, right? They're less mutable, they're less composable. So I want to impose, now how do we do this though, right? So this is a discipline that you have to impose it much farther to the left, right? The onus is on the developer very often to get the packaging side of things correct. This is their domain of expertise. This is their specialty. So how do we make it so that when they package something, it's reusable elsewhere, right? Let's remove sources of uncertainty. Let's remove the issues of network, my personal settings, right? This is stuff that makes it work on my machine and break on someone else's. We don't like those things. Remove those things as much as possible. And we end up, hopefully, with something that is reusable, right? I want to be able to say, combine the artifacts that I have or the recipes that I have and use them everywhere. Again, I think that the concept here is that of be able to create something, we call this a package, sometimes people call these modules, but something that could be reused. And that's kind of what I want to keep reiterating. And at the end, hey, once you have this, cool, you can compose all these things and make them enter into container-based workflows. We do want to end up there because that's where a lot of our orchestration tools are, that's where a lot of our automations, our runtimes, that's where they want to be. So we still want to be able to end up there. So make sure that if you do have a solution that allows you to do packaging, end up in a place where you can actually escape and get your, put it into your runtime, make your operations happy. So the superpower I found to be able to do a lot of these things has been a tool called Nix. And the nice thing about this is that it allows us to package something in a way that's distribution agnostic. It makes it so that I'm now isolated from my personal configurations. I'm isolated from a lot of these problems, but I still have the compositionality I've been looking for. I don't want to go too much into this. I'd love to talk with anyone about this for as long as possible, but the point is that there are tools that can help us address these issues. And I'm with a company called Flox. We're trying to bring Nix to the world. Nix is that open source side of things. And I want to kind of be able to make this more aware, make it more popular. And a lot of it really comes down to this notion of make things that can be reusable. And that's kind of the thought here, is make it packaging, right? Use that same ecosystem to develop and package and inspect my runtime and manage my runtime. I want a consistent set of tools for this. So let's see if we could kind of make that a possibility. A quick demonstration of what I mean by this might be in order, so I'll see how much of this is helpful or useful. So, let's say I have a piece of software. In this case, it's going to be really simple. It's going to be a wrapper around like hello world. Great. What does that mean? Well, to make this reusable, I have to make it so that anyone else can run this. Usually that also means I need to be other people to develop on this. Cool. So a person shows up and goes, hey, oh great, like I don't even have make on my machine. Like that's really bad. What do I want to do? Okay, well, let's actually get started and do some development. Cool. Get started. I'm going to get started. Cool. Now I'm ready to go. I have all the tools that I need. Let's say my operations department told me I need all this stuff. Everything needs to be in the right versions. I'm ready to go. Cool. Now I want to build my software. Everything's been built. Let's see if it works. Great. That's exactly what my application needs to do. Now what? Well, I want to be able to have all this also happen in CI. Well, why can't I just have that same sequence of operations run in CI? Because CI is just like a coworker. Just happens to be a little bit faster, and needs less coffee. But we actually want people to be able to run through, builds and make things and make artifacts that are immutable in this same exact way. So cool. All right, this is now up and running. What do I want to do next? Let's see. I actually forgot my own stuff, so let's see what I had next. Oh, okay, let's make a container. Cool, let's make a container out of this thing. All right, now let's load that container. And now let's run that container. Cool, so what just happened here? I just said, hey, that software I just made, that package, let's bundle it up and compose it, in this case on its own, but you can imagine even combining more and more things together. Let's put this into a container, let's load it into my current system, and let's run it. Cool, now the thing that I ran locally is exactly the same thing as I'm running in my runtime. So this ability to translate and transform something that was locally developed on into something that I can now deploy anywhere is interesting, because that gives me the composition that I want, but also the similarity between my local development and my runtime. That usually is a good thing. So that's a piece of that. Let's see, I don't know what else I want to show here. I want to run tests. Cool. I could run this sort of a test in CI. I could have my coworker run this. Again, it shouldn't matter. What else am I doing? Oh, what's actually inside this thing might be of interest. Not a lot of stuff. In fact, it's a little bit scary with all these things, but hey, these are right now all the different dependencies I need to run my little example. Cool, these are my runtime dependencies. This is essentially an SBOM. It tells you all the stuff that's up there, all the pieces of software that it requires, and it runs, and I'm pretty happy about it. All right, what else do we need to do? We could probably use those tags, all those hashes and things to keep track of software over time. Same way we would like to keep track of user events over time. So that's kind of a quick example of a piece of this, just to give it a taste. And one moment. Maybe I've lost. So here's the questions for the audience. And I kind of want to know how different companies solve this problem. So when you have multiple interrelated dependencies, how do you manage this? There's different ways I've seen this done, where you have one centralized model where this is the one place where all my software gets composed. That's where my lock files are that declare, at this moment in time, my company's view of software, of all my software stack is fully defined, fully locked down. Then there's also the, like, I have a bunch of independent projects, and they're all going to be operating on the, like, the trunk branch, and they're all moving along. CI is going to deploy them. They're going to run. That's an approach. We've seen leaf projects where you only have things that are in as leaf dependencies. So that way, they can depend on things from different moments in time, and everything kind of marches along, right? This kind of starts to decentralize things. There's also binary driven, where I just keep a track of, like, this is my current manifest. This is the manifest of the things in production right now, and it's defined not by the recipes, right, what often is in my Git repositories, but it's defined by here's what's in my, like, registries. Here's the containers I'm currently running. That becomes binary driven. And so my question is actually, how do you want to do it? How do you want to manage the situation when you have lots of different pieces of software that have to be composed together, lots of different services? There's not only there's a right answer here, but I'm trying to understand from people, like, what do they normally need? What do they normally want? What are they trying to solve? And then similar to this is, like, what then do you use as your source of truth? How do you know what currently is in production? How do you know what is currently in development? What are my developers using? What are my operators using? What are my customers using? And all of it, how do we make sure that we have good reuse of this stuff? So those are some questions. I want to kind of get ideas from people about that. Lastly, a little bit of a plug here. Flox is trying to bring the superpowers of Nix to the world. Some of these are the kind of the problems and issues I'm thinking about, and we're also hiring. And thank you for your attention. Any questions? Yes.
So, like, my organization, we use Yeoman and cookie cutter, and we do pre-commits and oh, great.
I can hear you. I'll just repeat.
Pre-commits that block people from committing, things that are not well formatted or not doing linting. And then we have, like, a developer local cluster that has an observability stack on it that people can send over OTLP their telemetry data to do validation. You're kind of, I'm trying to just wrap my head around all of this, but you're essentially saying that there can be one sort of holistic way to centralize a lot of these, like, tasks that you either see on the far right or the far left of things instead of one uniform way that can be improved upon or distributed as a, like, sort of an organizational best practice. Is that sort of the idea?
Yeah, so there should be the way in which I define that developer environment, right, as that person's doing that, should be extremely similar as what it looks like in production. And so it's not going to be the same, right, because the needs of a developer are going to be different. But we should kind of make it as similar as possible and be able to reuse as much as possible from that one context, for that developer context, and be able to use it in production, and vice versa. I should be able to take something in production and then start developing on it.
Okay. So, like, as a platform engineer or something, I have a backstage template that essentially encompasses a Flux manifest or whatever. Developer hits self-service, they start a new project or whatever, commit into Git, and then use this entire workflow to get into production.
Correct.
Okay.
Yeah. The key is I want to have a consistent software development lifecycle where I can use a similar, like, set of tooling, a similar set of vocabulary the whole way, rather than there being a big phase shift of, oh, now I'm no longer doing local dev, now I need to do prod, right? Those needs should kind of smoothly meld into one another rather than being a complete, okay, now we need a whole new team, now we need a whole new set of requirements, now we need a whole new set of stuff.
Do you see a conflict for, like, UAT testing where you have integrations from, like, third-party testers or consumers that don't necessarily exist on the local dev plane, but are later consumers of, like, an environment, like a UAT environment? And how does Flux kind of fit into that sort of testing?
I mean, if this is a situation where by design, it's not something that's going to work on my machine and your machine and your machine and everyone's machine, right? By design, that's a situation where we don't want that to take place, either because of licensing or because of costs or scale. then at the very least, it should in principle be possible to rerun that thing, whether that's because it's making some, hey, I can run an API call, maybe I don't have the keys for it. Hey, I want to be able to define that when it does get into that other, like, let's say, scanning framework, okay, conceivably, if I had that, or I was able to run this, or I did have a remote access to it, conceivably, I could run it. I could run it upon the same artifact. I just probably can't because, well, I'm not that vendor, let's say. So it's, yeah, in some cases, obviously, you're not going to have that kind of, I can run everything local, but at least in theory, you should be able to, and you should have the tools to be able to express that. Okay. That's all I got for the moment. Part of this is, like I said, I'm still trying to figure out the best way to communicate this idea, and I'm not 100% sure what the right vocabulary is, so please, if you have any thoughts or any ideas, or if you completely disagree, or if I just confused you, either way, please say hello. My name's Tom. Have a good day.